Welcome! In this video, we will explore the D Latch. A D Latch is a fundamental sequential circuit that stores one bit of data. It exhibits what we call transparent latch behavior. We will delve into what that means in the following slides. Let's start by understanding the basic structure of a D Latch. A D Latch has a few key inputs and outputs. The inputs are D, which stands for data input, and EN, which stands for enable. The outputs are Q, which is the main output, and Q bar, which is the complementary output. The circuit diagram will be shown on the next slide. Here is the circuit diagram of a D Latch. The circuit consists of two AND gates, two NOR gates, and one NOT gate. The data input D goes directly into one AND gate and also goes through the NOT gate before entering the other AND gate. The enable input EN is connected to both AND gates. The outputs of the AND gates are connected to the NOR gates, which form an SR latch configuration. The output Q is taken from one NOR gate, and the complementary output Q bar is taken from the other NOR gate. Now let's examine the truth table of a D Latch to understand its behavior. When EN is 0, regardless of the value of D, the output Q remains in its previous state, denoted as Q naught, and Q bar remains in its previous state, denoted as Q bar naught. This is known as the hold or memory condition. When EN is 1, the output Q follows the input D. If D is 0, Q becomes 0 and Q bar becomes 1. If D is 1, Q becomes 1 and Q bar becomes 0. Q naught and Q bar naught represent the previous state, indicating the latch holds or remembers its prior value when EN is 0. The D Latch has two modes of operation: transparent mode and opaque mode. In transparent mode, the output follows the input immediately, meaning Q equals D. This happens when the enable signal EN is 1 or high. In opaque mode, the output holds its previous value, meaning Q equals Q naught. This occurs when the enable signal EN is 0 or low. The key point here is that the latch is transparent when EN is high and opaque when EN is low. This is the timing diagram of a D Latch. The top signal is enable or EN. The middle signal is the data input or D. And the bottom signal is the output Q. When EN is high, the output Q follows the input D. This is indicated by the transparent regions in the diagram. When EN is low, the output Q holds its previous value, regardless of the input D. The diagram illustrates how the D Latch behaves as a transparent latch when enabled and holds its state when disabled. The behavior of the D Latch can be described by the following Boolean expression: Q equals EN and D plus EN bar and Q naught. This expression tells us that the output Q depends on the enable signal EN and the data input D. Let's break down this expression. EN and D means when EN is 1, the output Q follows D. EN bar and Q naught means when EN is 0, the output Q holds its previous state Q naught. D Latches have various applications in digital systems. They are used for data storage, acting as temporary memory elements. They are also used for data buffering, providing level-sensitive data transfer control. Furthermore, they serve as building blocks for multi-bit registers and are employed in control logic for enabling or disabling signal routing. These are some of the key applications of D Latches. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.